Welcome to the Todd and Noah show, taking the mystery out of electric motors.
Sounds scary.
It's quite ominous, I will say that. Once again, we have Noah Bethel, the Vice President of Product Development, with us.
Hello from sunny Tampa, Florida, broadcasting from sunny Fort Myers.
Sunny Fort Myers. A little rainy today, but there is peaks of sunshine out there.
Do you know
I don't know.
that in the day, I can't tell you when this was, but in the city of St. Petersburg, Florida, if the sun did not shine for any given day, that you get a free newspaper.
Really?
That's why I say sunny Tampa, Florida. You're going to get the sun sometime.
Well, because they don't want to give away free newspapers.
That's exactly right. Why would they do that if they didn't almost guarantee sun would be shining at some point?
Yeah. Well, and I am Todd Gunderson, the Vice President of Sales and Marketing, and thank you for that quick tip. That was like a tip that wasn't even part of the tip.
During the tip. That's a life tip.
That's a life lesson tip there. And if you stick around us long enough, you'll get a lot of life lesson tips because we've lived life around the globe, and we've got a lot of tips on fasting and eating and what to eat, what not to eat, and how to extend your life. That's, I think, as you can tell you're in an aging company when most of our conversations are not about, hey, what'd you do last night? What'd you do over the weekend? It's, hey, have you tried quercetin?
What's the new health initiative?
Are you taking vitamin K2, MK7?
How many hours do you fast now?
Right, exactly. Anyways, keeping in line with our tip theme, this is the second part of our PDMA tips, and these tips are going to focus on the Stator Fault Zone. So if you're ready, we can hop into the first tip, and that is kind of call us before you call the crane. And this was given to us February 22nd of 2016, and it's a large critical motors tripping, creating short-term losses in production. The production manager is asking you for a solution. You have a spare motor in storage, and it could be installed in a day if everything goes smooth. Maybe 2 days. But guess what? They did install the spare motor. It's brand new, and it doesn't work.
You know, it's the fear. Infant mortality, right? One of the things that we talk a lot about, and it's sort of, spinning off the tip, which is I spin off all the time, but is quality control. Right. And do you know what you have in the warehouse? And so one of the first areas of application of our portable technology in terms of the offline capability is in the warehouse, verifying that what we have in a warehouse is in fact good. And a lot of times it's not. Yeah.
So, when we travel and we do testing, when we go out in the field, that's usually the first place we go to.
Oh, absolutely.
The warehouse. It's the easiest because there's no power supplied to it. But these are all motors that have just been brought to you, and sometimes, not all the time, but sometimes you get this anomaly, high resistive imbalance or low resistance to ground. Now, if it's a low resistance to ground, maybe it's because it's been in an environment where it's absorbed moisture.
Almost for sure.
High resistance connection or an inductive imbalance.
Yeah, and there could be animals living in it. I mean, a lot of times we've seen, you'd be surprised. But remember, they used to warn us, hey, before you open up the switchgear, you got to test it for mice because it was causing some kind of disease. It's a dangerous environment that we work in.
I've never had that.
Yeah. See,
where have you been testing motors?
In the deep.
I guess so.
Yeah. In fact, I think this was more likely, it was up north in the Great White North. But anyway, back to the warehouse, right? Sea story. I was traveling to visit an aluminum facility, and as we're walking through, remember we said we go to their spare motors and test it. Well, we walked through and I saw a bunch of junk motors piled in an area, and I said, "Why are you keeping your junk motors here?" At which time they told me those are our spares. That was the warehouse.
Yeah.
Now, this doesn't happen today, I'm sure. None of our listeners would do this.
It might. We've seen some locations that are a little suspect.
They're obviously not listening to our tip of the week or to the Todd and Noah show. But after I took my foot out of my mouth, we tested some of those warehouse motors. And does it surprise you at all that they weren't in great shape?
Yeah, it always has a fresh coat of paint on it, right? So it looks brand new. But you want to dive in deeper. You want to make sure that it's not just lipstick on a pig, right?
Exactly. Right.
You want to make sure it's not lipstick on a pig. So in this case here, this was a simple mistake. And it's hard to show like a mislabeling of a wire, but when we wire a motor together, Y wound 4, 5, and 6 are tied together, right?
Mm-hmm.
But then 5 and 2 are. What if we just took 2, and instead of 4, 5, 6, it was 4, 2, 6? And it immediately popped out in our inductive imbalance.
Right. Here's the problem: is this was tested. Right. What I mean by that is that when the technician rewinding the motor originally, right, where they've got these 6 leads hanging out and they're, putting them together resistively, even with an inverted phase, as you're describing, resistively, it's balanced. Right, you're going through the same conductive path with a phase resistance measurement, and so if all someone is doing is taking a multimeter and measuring resistance and feeling pretty good about it without doing some kind of rotational test, they would not see this.
So, in fact, what they did is they didn't have the ability to check inductance immediately. They had a megometer, which showed no resistance to ground issues.
As it wouldn't expect it to.
Face-to-face resistance, I don't think.
Would be balanced.
I
think they could, you could put a multimeter on it and see that. Not in any accuracy levels, but nonetheless, it gives you a false indication that everything's okay.
Yeah. But then inductance
immediately.
Was the problem.
Yeah.
Immediately showed the problem. So going to the next tip, which was December 19th, 2011, let the new guy start the motor. This is a classic Navy.
Great phrase.
It's a classic Navy, probably any military. Oh, bring the new guy in. Let him start this asset up. Oh, we didn't do it. It was a
nub, we called him.
The nub, the newbie.
Yeah.
In this case here, we let the new guy, let's say we blow a fuse. How many can you replace? Or how many times are you allowed to replace a fuse?
I believe the general consensus is 1.
Okay.
In case it was a faulty fuse, like a weak, it was aged, whatever. I don't like that rule. I think you blow a fuse, run a test. Just do a quick check.
Why not? It's a standard test you could do. You could get all the inductive imbalances within 3 minutes, like we said earlier.
Absolutely.
So if it's a new guy starting the motor, you're allowing 1 blown fuse, essentially.
Yeah, we use that phrase basically to kind of identify if you don't have any ability to test. Like say you put a brand new motor out of the warehouse and you're crossing your fingers that it's in good shape, but you don't have any offline capability, you don't have any power quality assessment capability, then at least let the new guy start the motor.
Yeah. So this next tip is April 16th of 2007. And it's kind of correlating. Once again, we're talking about this correlation of different data points. Current imbalance and impedance imbalance.
Absolutely.
For a stator anomaly. Why the two? Why do they correlate together?
So what's interesting about the relationship between these two is I always used to refer to current as it's a very generic indicator, right? Motor draws current when it's up and running. But much like, your alarm system at home, like at my house, if my alarm goes off, I'm trying to figure out, are the kids sneaking in, sneaking out? What direction are things going? Sorry, kids, for letting all that in.
Hopefully they're not sneaking out.
Well,
although you don't really have any
know.
kids that you have to worry about anymore. They're all of age.
That's true.
They'll be saying, I'm going to call the cops if you keep me in here any longer,
They're
Dad.
survivors. That's
See
right.
ya, Pops.
That's right. They're out. But, the idea, it's current's the same way. If you see a current imbalance, you're really not sure. Is it upstream to the transformer? Is it downstream to the motor? Current is a global indicator. And sometimes it can be a late indicator, right? So you don't want to rely solely on that. Impedance is very different, right? Impedance is actually now using phase angle relationship of the voltage and current and allows us knowledge of which direction we're looking at. So one of the things we always say is if current imbalance is going up by itself, then you're probably dealing more likely with something downstream, or I'm sorry, upstream. It could be a voltage-induced kind of scenario. Where current, when you put a current probe onto your cable and you measure it, the problem could be line side or load side of where you're connecting, and it's still going to show it. Voltage is very specific. If you hook up voltage at point A, and there's a problem line side, you will see it. Sorry. If the problem is line side, you'll see it coming to you as the voltage connection. If the problem is load side, like down at the motor, you won't see it for the voltage. So we really like to correlate these two and not make a call on one. And the two tend to go together. The other thing is a relationship in terms of the percentage. If it's a real stator fault, the impedance imbalance is often going to be as much as double the current imbalance. If the current and impedance imbalance are matched, let's say like 7 and 7, 7% current imbalance, 7% impedance imbalance, 11% current imbalance, 11% impedance imbalance. If they're matched, we're going to lean to a power circuit anomaly, a high resistance connection, something causing, that. But once the impedance imbalance starts to as much as double the current imbalance, we're focusing on the stator.
Okay. And once again, we're talking about, when you talk about impedance, you're talking about inductive reactance. And in inductive reactance, which is 2 times pi times frequency times inductance, it's inductance that's changing.
Yep.
Which is changing the inductive reactance, which is then changing the impedance imbalance.
Exactly.
So there's math behind. It's not just smoke, as we call it. There's actual numbers that we're dealing with here, and then
quantitative changes. That's
changes. And so the next tip that we talked about really just kind of goes into what you had just said, March 4th of 2019, qualifying impedance imbalance, where you said if the current and impedance imbalance values are similar but high, maybe power circuit anomaly.
Right.
However, if the impedance imbalance is substantially higher, maybe than the current imbalance, then a stator anomaly becomes a primary concern.
Exactly, and there's a big warning that we like to throw out there related to impedance imbalance. Motors are designed to run at 80%, right? It's kind of a big deal.
So if it's unloaded.
Exactly, right. If the motor's unloaded, you're going to be dealing with phase relationships that are off balance, right? So it's important to establish knowledge of that, that if you get under 60%, the impedance imbalance may be as high as 11, 12, 15%. You don't want to take action on that. So that's what's important about when we say, hey, don't wait till a motor's running at 100% to take a test. Take it every chance you get.
Yeah.
And then that way you establish a norm. If at 50% it's 10% impedance imbalance and at 80% it's 2%, you know the range, and that's important.
And so when we see something like this, if we see, we say it's a current imbalance plus a higher impedance imbalance, we would then recommend, well, let's secure the asset. Let's do a rotor influence check. Let's look at it phase-to-phase inductance. Let's see what that's doing. And then correlate offline, online data.
Absolutely, because when it comes to a stator fault, you don't always have a lot of time to make good decisions, right? So it's a situation, we used to always tell people that a lot of the technology that we're applying and the data that we're collecting, we want to identify conditions that are conducive to a stator fault so that we can clear them. And that's everything from a winding imbalance to an insulation integrity problem to a vibration, excessive vibration, a rotary defect. All these things can lead to movement of the stator windings, breakdown in the insulation, interturn, whatever. So find the problems, fix them, correct them to extend the life of the motor and push off a stator fault.
Yes, because once you have it, it's not curing itself.
Especially on a form wound motor, right? So once you get into the form wound coils, the individual turn resistance or impedance is so small that it ends up basically creating like a shorted secondary of a CT. So you got so much current flowing through that shorted turn that it pretty quickly burns up.
So June 1st, 2009 is another tip that we're going to pull out here. Current imbalance. And you talked about this a little bit. But remember that it is very common for an unloaded motor to operate with a high current imbalance.
Right.
10 to 15%.
We jumped the gun on this one. Yeah, absolutely.
May
exactly
drop
what
to
we just
2%.
said. Absolutely. We see it all the time. 15 to 2% is not that out of the question when it comes to unloaded to loaded.
One thing that we also talk about with current imbalance, and it's not necessarily in this tip, but we correlate it with voltage imbalance, and it determines in the power circuit, where are you testing? Right. So if you see let's say you're troubleshooting and you do a power test and you see a voltage and a current imbalance at the T-leads in the connection box. Well, we're pretty confident that the issue is where?
Upstream.
Absolutely. Of it. But if it's just a current imbalance and no voltage imbalance, then we think.
Right. And it's interesting because there is kind of kind of a relationship that is formed. For every 1% voltage imbalance, it's not unusual to see a 7% current imbalance. Now, not guaranteed. But that's why we do want to pay attention to voltage imbalance. And like you mentioned, if the transformer is sending out imbalanced voltage, if you're at a facility that is heavily loaded on one phase and you're running with a 1.5% voltage imbalance, realize that between 7 and 10% of the current imbalance may be driven purely by that. Other countries that we travel to don't always have the same strict controls of the voltage and frequency coming to a plant, and so not just voltage imbalances, but lower voltages can be an issue as well. But certainly that relationship between voltage and current is very sound, even when you're looking at the power FFT, right? If you're running a spectrum on the voltage and current signals, a lot of Don D'Onofrio, a longtime user of the technology, he always likes to look at voltage and current imbalance. And you look at the spectrum, and if the current peak does not have a voltage peak with it, he really starts to dive into the motor side. If every current peak has a voltage, then that means everything's coming down from the power quality side, and it's driven by the power system. As long as you don't have any major power system issues, he'll dismiss those because the current peak has a voltage peak with it, as long as it's within a certain boundary. So it's a great comparison.
So March 16th, 2020, I'm sure you know what was going on that day.
Whew. Of course.
Close to COVID starting.
The day after March 15th, 2020.
That too. I think we're real close. I think I was going to be heading to a hockey game, and then they canceled everything.
Unbelievable.
Everything got canceled.
Yeah, that was if I'm right, though, that was a Stanley Cup year.
Well,
or is it 20?
I don't know if they canceled it, but then they started. Remember, they did it in the bubble.
Oh yeah, it was in the bubble
up in Canada.
But Lightning won the whole thing. Our home,
the Tampa Bay Lightning.
Yeah, those guys.
One of the best hockey leagues.
I can't argue with you there. Very exciting
on the earth. Good thing we're season ticket holders.
Starting up
to
pretty
it.
quick.
Next month, maybe.
I'm eager to get into that.
Depending on when this drops, it could be next month, or we could be 6 months into the season.
Well, that's true. Yeah.
And we're in the lead of the division, so we're soothsayers. All right. Impact of voltage changes on current. Changes in voltage have a significant impact on current. And you had just mentioned this, but starting current and running current respond very differently. A drop in the line voltage will result in lower starting current and higher running current. A rise in line voltage up to 5% will increase starting current and slightly reduce running current.
Absolutely. If you see us at a trade show, what do we like to hand out? These little ESA handbooks?
The ESA handbooks.
They have a great graph that kind of shows the impact of voltage. And, for the most part, you want to maintain your voltage values within 2 to 5%, right? Of the normal voltage, of the design voltage. Once you get to 10% lower voltage or 10% higher voltage, now you're really affecting things and reducing the life expectancy of the motor, and that's a big deal. So it's kind of weird in that, and it's interesting how the power affects current. The running up and running versus the startup, and can't say enough about that impact because we watch startup current, and if startup current drops, we start to lean towards rotor bars. We talked about that in the rotor tip of the week and different things, or the podcast. But one thing we always tell the customers, hey, don't forget to look at voltage. Because if voltage also dropped, if for some reason the bus voltage was low, like I mentioned in other countries, sometimes it varies a little bit, that can give a false indication because a lower bus voltage is going to be a lower current, it's going to be a lower torque, longer startup, right? So we have to at least be smart and look at other indications.
And if it's a stator fault on an inrush startup, we say just the opposite, right? It's higher current on startup.
Right, stator faults, and we're talking about like turn shorts. Now you're reducing the number of turns, you're reducing the impedance of the circuit, and as a result, you're like an Ohm's law, right? That initial transient current is really an Ohm's law product. Yeah. So if you think about voltage over resistance equals current, right? So we apply 460 volts, and you've got a certain resistance, and boom, and then with an AC signal, it's called impedance. So voltage with a certain impedance creates a certain current. Well, if you've dropped your impedance significantly because of the turns loss, well, now you've got a much higher current. And a lot of times it'll get to the point where it trips, and that's where the troubleshooting starts.
Yeah. So on talking about stator still, high potential testing, How much is enough?
Well, there's a lot of standards that support this, right? And so whenever we're asked this question, we always say, listen, there's a time and a place for overvoltage testing. Our technology
We
itself.
even have a statement that we give out.
We do.
Based on NEMA, IEEE, ESA.
Absolutely. These are the Bibles of the electrical testing industry. Absolutely.
Yeah, all of their recommended
And you know
best
who
practices.
really needs to be aware of this is the service shops, the service companies, the service shops that are actually performing this overvoltage test. Back in the day when I had a different color hair, a lot less wrinkles, and a lot smaller mortgage, we would show up, and it wasn't unusual for a motor to show up at a shop, first test, bang, overvoltage stress test, see if it fails or not.
Yeah.
The mindset at the time was okay, but that was the norm, right? And if it failed, you're not just going to get new bearings, you need a new winding. Well, it's to the point now where there's so much data available in the field, right? So the motor owner often knows the condition of the motor before it goes to the shop. So any overvoltage testing anymore is almost like, hey, get authorization, pre-authorization before overvoltage has occurred.
Yeah.
And we say the same thing here. We're just walking through another case study with a group that effectively, we got a lot of variable frequency drives that'll trip and raise questions. Is it the motor or the drive? 30 years ago, it was always the motor or the pump. Which one is it? Today, it's as much the motor versus the drive, and that's a common conversation. But in this situation, they weren't sure whether it was the drive or the motor. And again, it goes to the shop. There's some over voltage stress testing, and now we're not really sure, right? The ground wall gives out, and what was the real root cause? So, yes, be careful. Be absolutely careful. Most of the standards are not designed to be over voltage stress testing a motor in the field with dirt or contaminated windings.
And once it's in the field, you can rest assured
it's not clean.
It's not clean anymore.
Not anymore.
Not anymore. Okay, going to April 25th of 2016. Why? Why start Delta Run? Can you talk a little bit about that?
Yes.
And what we would look for there as far as testing, and why even have a why start Delta Run? I assume it's for current control.
Good sea story.
Yeah.
Back in the pre 9/11 days, the first bombing of the towers. If you remember, there was a big explosion underground, right? Train Air Conditioning, great company. Everybody knows. Probably they're both commercial, industrial, as well as residential. Mm-hmm. Well, they had a lot of grid. Not grid. Sorry. Basically, a whole system of air conditioning units were lining the streets, to cool the building because the explosion took out some of the site air conditioning capability. So you had hundreds of these 1,000 horsepower Train air conditioning units, right, cooling the towers. Well, once the towers were up and running and fixed and corrected, well, then they sent them all to various places. One of them ended up in a chemical company somewhere near Louisiana. And we showed up to troubleshoot the thing. Well, it was a why start Delta Run, right? The big thing is they had a 1,000 horsepower motor connected to a 480 volt system. That's a lot of horsepower on a low voltage
system.
Absolutely. So they're going to trip breakers or shut all the lights off if they start this motor on a straight on delta, right? So what they'll do is they'll start on Y. Mm-hmm. It controls the current a little bit, gives it a torque variation, doesn't shut the lights out. The utility company doesn't call and say, "What are you doing?" But that's kind of the theme behind that. So what do? Well, it's important for us to know that it's a Y start Delta Run. We would love to see that transition. Kind of falls back to the whole, if we could get the entire startup cycle through the Y and the Delta transition, it's great. But if you show up with an MCE to do offline testing, QA, something like that, you want to make sure that you're approaching this wisely and in testing it in a Y or a Delta, and being aware that a lot of times the problem is at the starter, and you got to be able to test through that starter. So what you can do is sometimes people will take external remote control or power, external power, and close those contacts so that we can test through them and verify that things aren't messing up at the contactor level. So just some test considerations.
Okay. Inductive imbalance, part 1, 3 years ago. I don't have a date here. No date on this, but it was 3 years ago. Could be 3 years ago today, which would have been 2021. Stator rotor air gap fault zones can be evaluated in the AC standard test. Phase-to-phase inductance measurements, right? What can you find from a standard test for the stator?
So we say 3.5 minutes goes a long way, right? If you walk into a motor, it's in the warehouse floor or it's installed and you're at the starter testing from the T leads or whatever. The big thing related to a stator that we focus on is inductive imbalance, right? Now, we don't dismiss resistive imbalance either.
Right.
A lot of times not necessarily a 4160 volt motor, but if you're down in the low voltage 460 volt range, a lot of times the coils that are made aren't made with a single strand of wire, right? You've heard of 3 in hand or 2 in hand. They'll take, 2 or 3 strands of wire and run a coil with that. Well, what's interesting is sometimes it's not a turn short, it's an open. Right? And if you have a 3 in hand with 1 coil open, we'll see a bigger resistive effect than we will inductive, right? Because there is mutual inductance that occurs. And again, even though you have 1 lost turn, sometimes it has a bigger effect on the DC resistance measurement, right? So, but we still focus a lot on the inductance values in terms of the offline tests. So, when you talk about earlier in one of the podcasts, you talked about permeability as a major variable in the inductance equation, right? And so any change in permeability, which is even the air gap, as you mentioned, that'll change permeability. Obviously, if you take the rotor, and generally the rotor is dominated by either the steel, which is a ferrous material, or the aluminum bars, which is a non-ferrous material. If it's a small enough motor that the aluminum actually plays a bigger part in the air gap, then your inductance actually goes down with the rotor in. If the rotor is out, it'll actually go up in that situation. But if the rotor's dominated more by the steel influence of the laminations, then it actually drives the inductance up because the permeability goes up. Right. Same thing with with almost any type of inductance calculation.
So if we saw a current imbalance, an impedance imbalance, we secure the asset. We would also want to see a high inductive imbalance and then also a rotor influence check, right? That would
Always
separate the 2 up, 1 down, or 2 down, 1 up, depending on what type of winding, whether it's a Y wound stator or a delta wound.
Part of that
stator.
birth certificate we talk about a little bit is, is it a concentric wound stator winding where you've got a different, literally almost a different number of turns, different size of turns. It can make a big difference on the inductance, and we need to know that. So that affects that when you do a RIC test and you're rotating the rotor and you're rechecking the inductance of the stator, each phase should be affected the same, right? And it's just a real easy tool to separate the rotor influence from the stator influence, right? We see this a lot, and if you've got a high inductive imbalance and you do a RIC test and all 3 phases are acting the same, guess what? It's probably not the stator.
Yeah. So when we look at the rotor and the RIC, and we did a rotor testing tip, and you said the field collapses, and then it basically because at the crack.
Right.
Field collapses.
Well, the cage itself
the cage collapses, but the field expands.
Right. With the crack, it actually expands. Right.
Just the opposite kind of where when you do a rotor influence check and you're applying the high frequency field to the stator and you're rotating the rotor, that just as that crack goes through each phase, you see an issue.
It'll affect A and B and C all the same.
When you have turns as a fault, you've lost turns, we start to see the whole graph change.
Right.
Because every test you take, it has a change in inductance.
Every test for that phase drops.
Yeah.
Absolutely.
Phase 1 to 2, 2 to 3, 3 to 1. Let's say it's on phase 1, so 1 to 2 and 3 to 1 are always going to be affected. If that's the case, which 2 are the same? Phase 1, that's where the issue would be at.
Right, and this is one of those call us before you call the crane.
Yeah.
Anytime you're evaluating the qualitative rotor influence check, with experience, your ability to know the difference between a stator anomaly versus a rotor anomaly versus a concentric wound or an eccentricity indication, there's some time on the pond that does help a lot. I can't say enough about a baseline. Get that RIC as a baseline, and it makes the next troubleshooting event so much easier.
Well, Noah, that takes us to the end of this round of tips on the Stator Fault Zone. As we had mentioned in our previous tips, if you have a tip that you'd like to share with PDMA, we can certainly get it out on our Tip of the Week format, and you might get some swag as a result of it. Like we said in one of our earlier podcasts as well, we're really we really try to train the technician out there to make them better technicians. We can only be better if we're a little bit more, if we're more knowledgeable about what we're trying to do out in the field.
And
it can only help us.
You come into our facility, us coming to your facility, online training, you name it.
Or just calling technical support or going out, because it probably works best when you're out there testing. We always say, well, first you start to crawl, and you start to walk, and then, you're not going to hit the ground running a marathon or a 100
For sure.
meter
In
sprint.
fact, we almost don't even like to sign people up for a data analysis class until
right
they've
away.
had the technology for 6 months
while.
to a year. Get used to it. It makes the course so much more effective to have
It's
experience.
like anything in life. You want to be able to kind of slowly ramp up and then stay with it. You play a musical instrument. I play a musical instrument. Practice means everything, so you got to get out there and use it. And then just build. You only get better if you use it over and over
Absolutely.
and over again. But use technical support. Anyways, having said all that, we certainly appreciate you guys listening on this was our tip series, Stator Fault Tips. And if you, like we said, if you have anything that you'd like to share with us, please feel free to pass it on to us, and we'll definitely get you some swag and maybe get it posted on our Tip of the Week section. Until then, you guys have a great day, and we'll talk to you real soon. Thank you.